Today we want to talk about some unusual test equipment. This is similar to a DMM, but it's not digital. It's an analog multimeter, and it's a little old-fashioned, but these things are still being sold, and some of them are actually pretty expensive because of their accuracy. This is a cheaper one. I think I bought it on sale somewhere, but what these are used for, the analog versions, they're a little harder to use, but they do have a good purpose. What they're used for is if you actually wanted to see a needle movement, because that's what this thing does, is it has a needle that'll transition across the screen that's marked in different calibrations, and what it'll show is an actual movement. And sometimes you want to see, as you're working on a circuit, maybe peaking something up, you want to see when it reaches the apex and then starts to back off a little bit. So there are purposes for this. Another reason might be too, if you wanted to see some sort of a fluctuation, that was happening, where you would see that meter movement periodically jumping a little bit. It's a little easier to use in some instances than a DMM. So this is an analog multimeter, a little tricky to use, but we'll take a look at that and see how to use that. This, I love ESR meters. This is an ESR meter, and I think that stands for effective series resistance of a capacitor. These things only check capacitors or low ohms. They can also be used for checking very low ohms, but they're mainly used for checking capacitors in circuit. So that really saves a lot of time and effort, not having to desolder a capacitor and take it out, measure it, and then putting it back in and resoldering it if it's good. This thing will check them in circuit. Yeah, it's a pretty cool trick. What it does is it actually sends a signal through the capacitor and checks to see if it's passing through while it's in circuit. All right, then the next thing is a capacitor tester. So this is more accurate of a capacitance reading, and this, though, you'll have to take the capacitors out of the circuit. So you'd have to desolder them from a circuit board, and then you could run a test on this, and it'll give you the actual value, a very accurate value of the capacitor. And then last but not least for today, this is an LCR meter, so it does pretty much everything. It'll test L is the letter for the inductance, the coils, the C for capacitance, and then the R, LCR, R for resistors. So it does pretty much everything. I only really use it for inductors because I have other test equipment for capacitors and for resistors, but this is sort of an all-in-one. And the inductors normally don't go bad very often, and they don't really change their values much at all because it's a wire that's wrapped around a core. But sometimes, if someone puts too much current through the coil, you can open it up, and that can be tested with a DMM for resistance. If you see an infinite reading and open, then someone, popped it by putting too much current through it. That's usually what will happen as far as them failing. The other thing could be if maybe some of the windings shorted together, but that's a little unlikely. But that's possible where it could change its value. But more than likely what you're going to run into using these things for is if you have a coil, an inductor, and you're not sure of its value, because sometimes they're not marked very well. So just to double check to make sure that it's the right coil for the application, you could always use this and get a reading of the inductance. So we'll take a look at some of this stuff. It's pretty interesting stuff. All right, we're going to check a 1K resistor with the analog multimeter. So you go to the ohm setting, and it shows me that it's green, and that kind of directs me to the meter section that's got the readout that's in green. And vice versa for the voltage readings too, So I'm looking at the scale that's up on the top, which is the ohm setting, and I'm going to go ahead and zero the meter. So I have to put the meter leads together, make sure you're getting a good connection with the meter leads, and then you're going to go ahead up to the zero calibration dial there and make sure it's right at 0. Okay, and whoops, a little bit tricky to get that right on 0. Then once it's zeroed, all right, that's good. I'm on the times 10 setting, so what that means is whatever I get a reading of, the number has to be multiplied by 10. So I get a reading of, it looks like about, it's about 80 really. not very accurate down there. See, it's too far down, so that's not a very accurate reading. I want to get more deflection. The more deflection, the better, so I can change scales. I'll go to the 1K so I can get a little bit more accurate of a reading. And I hold the leads together again, and I'm going to have to go ahead and re-zero the meter. Every time you change a setting, you have to re-zero. A little bit of a pain, but like I say, sometimes you want to use these analog meters. And now when I go ahead and test that, it goes right up to 1, right on the money. So it's 1 times 1K, and there we have it, a 1K resistor. Now if I wanted to, verify it, I could always use a digital multimeter. The digital multimeter is much more simple to use. I just have to, on this one, it's not auto ranging, so I do have to pick the right range. So I'll pick 2K, so that means I can go up to 2K. It'll read anything from 0 to 2K, and when I hold the 1K across there, it should give me a very, very accurate reading. Okay, there we go. So, and that's given me 0.995K, or 995 ohms. So boy, that is really right on the money. These have a tolerance of plus minus 5%. So I'm really looking good with that number. So next we're going to test the ESR meter and see how it reads capacitors in circuit. This is an Arduino board minus the IC that's being used in a project right now, in a standalone Arduino project, but this is the development board, and there's a barrel connector. The barrel connector can accept up to about 15 volts. You might have 12 volts from a car battery or something like that. So you can stick it into the barrel connector, and right next door to it, there's a, let me point it out here, there's a voltage regulator that's right next door to the barrel connector that'll give you 5 volts out. Now to make sure it's a nice clean 5 volts out, there's a couple of capacitors there that act as filter capacitors. So they're in circuit, they're surface mount, might be a little hard to test, but we'll go ahead and check them with our ESR meter and see how that all works out. So using the ESR meter, we have to go ahead and zero it out, similar to how we had to do the analog volt ohm meter, our multimeter that was analog. Here though, it's simpler because we just touch the leads together, and once they're touching together, push the 0 button, and there we have a 0 reading, so we're good. 0 when we're making continuity, and whoop, let me make sure I'm getting 0. Yeah, okay. When they're touched together real solid, they're 0. So what I'm going to test now is those capacitors. Let me check one, and you have to observe polarity, so I'll go ahead and put the negative over here on the surface mount part and the positive on the other surface mount part. A little hard to get at, but there we go. I got a reading of 1.3. So that's cool, 1.3. Now that's in ohms, but what does that mean? Well, that's a 25 volt, 47 microfarad capacitor, and there's a nice chart on these ESR meters that you look at, and it says, okay, 47 microfarad, 25 volt, should be about 1.2, and I was 1.3. I'm happy with that. That's pretty good. So no desoldering or resoldering needed whatsoever. Okay, so getting to the capacitor meter, let's check a capacitor out, and this capacitor happens to be a 10 microfarad capacitor. And the ESR meter is just basically for troubleshooting, but now we should be able to see a pretty good indication of the actual capacitance. And they're polarized because this is an electrolytic capacitor, so we observe the proper polarity and try not to drop it on the floor. Okay, so here we go. Observe the proper polarity, and we'll connect this thing up and see what we have here. So it's not auto ranging, we have to pick a scale. So if it's a 10 microfarad, I'm going to go to the 20 microfarad setting, and now I should be able to read the capacitor okay. So it'll read from 0 up to 20 microfarad, and it's a 10 microfarad, and it's reading 9.6 microfarad, so that is pretty close. If you could see the 9.6 on there, that's pretty good reading. Alrighty, because you're allowed plus and minus 10% on capacitors. Now here's lastly but not leastly, here's our LCR meter. So this thing will check L is coils, which is what we're going to check. C is capacitors, and R resistors. All right, so let's go ahead and check that out, see how that's going to work for us. Hopefully you can see the reading there. Let me kind of zoom in a little bit. Okay, so a little bit of zooming in, and we see that it's just showing us a 1 overload. Now here's my coil. This coil happens to be a 1 millihenry. So I picked that range. Again, not auto ranging, so I have to go to L, because that's what I'm testing. It's got a LCR switch. I go to L, and it's a 1 millihenry, so I'm on 2 millihenry. It'll read up to 2 millihenry. No polarity needed on this because it's a coil. And when I go ahead and make sure I get a good connection across there, it's reading 0.853. So if you could see that, okay, it's 853, 852, and that's beautiful because, you know, again, there's going to be a little bit of tolerance that we have to deal with, and that's pretty darn close. If you round it off, you have 0.9 millihenry, and this is a 1 millihenry, so that's good. 10% off. That's okay. That's fine. That's what they're allowed. So, you know, you never know when you might have to use some of these meters that aren't very, very popular. Of course, the most popular of them all, and the meter that I would want if I was on a desert island, would be the standard DMM. But sometimes you just need to get, you know, some different readings with some of these specialized meters.